Welcome to Dataless U. I'm Paul, coming to you from Brooklyn. Today we're going to take a look at the law of sines. So let's get started. Open up to page 345, good old trusty Richard G. Brown's Advanced Mathematics. On this page you'll see the lesson on the law of sines, and I just want to briefly review the lesson, and then we'll turn our attention to a more difficult question later on in the chapter. So, in general, the law of sines is used to solve triangles, non-right triangles. Of course, if you have a right triangle, you can use regular old right triangle geometry, SOHCAHTOA, and so forth. But let's say we want to solve for the side lengths of a regular triangle, given just a few pieces of information. So, for example, look at the triangle on page 345 and up here on the big board. You see we are given that side AB is 25 meters, angle A is 110, angle B is 20 degrees, and our task is to find A and B. Well, that's simple enough using the law of sines. So notice I've written the law down. The law of sines says that there is a relationship, there is a ratio between the sine of an angle and its opposite side. In other words, the sine of A over A, which would be the length of side A, which is the side opposite angle A, is equal to the sine of B over side B, which is also equal to the sine of angle C over side C. It's an elegant law. It's one of the more beautiful principles in trigonometry, and let's take a look at how we apply it. So in the bottom triangle, we're given two angles, but of course we can solve for that third angle simply, because we know that in a triangle the angles add up to 180. And so if we have 110 and 20, that's 130. Well, that leaves us 50 degrees then for angle C. Then we can just use our given side of 25, which is of course opposite the 50-degree angle, as our kind of basic ratio. In other words, the sine of 50 over 25 is equal to the sine of, let's start with A. Let's solve for A first. That makes sense. Now, look, the angle opposite side A is angle A, and that's 110 over A. That's simple, right? Then when we cross multiply and divide, we'll end up getting A equals the sine of 110 times that 25 divided by the sine of 50. And you can plug this into your calculator. Be sure you're in degrees. And for A, we get 30.7. Right? So that means that this here is 30.7, right? And that we've solved for the first mystery side. Now, let's solve for B. To solve for B, we do the same thing. We say that we know the sine of 50 over that opposite side 25 equals then the sine of 20 is the angle opposite side B over B. And then again, when you just cross multiply and divide, we will get that 25 degrees, I'll put the 25 first this time, times the sine of 20 over the sine of 50. And again, you can plug this into your calculator, be sure you're in degrees and not radians. And for B, we get 11.2. All right, so that's generally how you apply the law of sines. Make sense? Now, the challenge is then you turn to a later page in the chapter, or you sit down for your exam, and there's a more challenging question, a more interesting application. So I want to now take a look at the problem on page 357, and it's number 23. I'm just going to go ahead and read it. You'll notice I've drawn the fundamental diagram up on the big board. It's a navigation question. We could pretend that we're pirates on a ship, looking perhaps to storm this island. It says a ship is steaming north at 6 knots, that's 6 nautical miles per hour, when the captain sights a small island at an angle of 15 degrees to the east of the ship's course, as shown to the right or up here on the big board. After 10 minutes, the angle is 28 degrees. How far away is the island at this moment? So essentially, how far away is the island at this moment? That means we want to solve for this line here, this x. So from here, right, I'll just kind of retrace it in green so we see what we're trying to solve for, all the way out here to the island. And you can do this using the law of sines. In many ways, the hard part in math or in trigonometry is sort of figuring out how to go about solving a question. Which principle should I apply? So let's think this through. It says that we can see the island at an angle of 15 degrees to the east. So that's down here. Right, this 15 degrees to the east, that means to the east of due north. So the ship is headed north. We can turn our eyesight 15 degrees east of due north and see the island. All right, and then we travel 10 minutes. Now that's kind of tricky. It says we travel 10 minutes, right? And it says we're traveling at, what does it say, 6 knots. All right, now that's just a fancy term for 6 nautical miles per hour. Well, if we're going to go 6 nautical miles per hour, right, 10 minutes is a sixth of an hour, right? We could think of 10 minutes as 1/6 of an hour, right? And we're going to travel then 1/6 of those 6 nautical miles per hour. In other words, we're going to just go 1 nautical mile. So I'm going to label this side of the triangle 1, and that's in nautical miles. We'll worry about translating it to regular miles at the very end. Don't even worry about that for now. So now you see we're beginning to fill out our triangle. We have 1 angle measure at 15. We have 1 side length at 1. So let's see what else we can figure out. Because we have this 28 degrees, well, we know along a straight line is 180. So we know that this angle here is 152 degrees, right? 180 minus 28 is 152 degrees. Well, given that we now have 2 angles in a triangle, anytime you have 2, you have 3, because the 3 of them have to sum up to 180. So you just add 152 and 15, get 167. 180 minus 167 leaves us with 13 degrees up here. Now, once you have all the angles in an irregular triangle, you know the law of sines is the way to go if you're trying to solve the triangle. In other words, figure out all the side lengths. In a future video, we'll look at the law of cosines, and you'll use that when you don't, in fact, have all 3 angles, when you just have 1. But now we have all 3, and we have the opposite side length of the side opposite the 13-degree angle. So we'll use that one as our kind of fundamental proportion. In other words, the sine of 13 degrees over that 1 nautical mile has to be equal to, well, we know we were trying to solve for that x, and which angle is opposite x? You just kind of use your eye, kind of look, oh, opposite the x was that 15 degrees, right? So that means we'll put that in the numerator, the sine of 15 degrees. Simple enough. Cross multiply, divide by just the 1. We end up with x equals the sine of 15 degrees, for good measure we'll write times the 1 nautical mile, over the sine of 13 degrees. And plug that into your calculator. Again, be sure you're in degrees. And you get 1.15 nautical miles. which in a way is the answer. But we don't generally think about how far away something is from us in nautical miles. We think about miles. Let's just quickly convert that. I can give you the conversion. 1 nautical mile is equivalent to 1.15 miles. And don't be confused by 1.15 showing up again. That's just a random coincidence. So if we have 1.15 nautical miles, how many actual miles is that, right? So you just, again, cross multiply, and we get in actual miles 1.32. That's how many miles away this island is at the moment. Right, so maybe these pirates just want to know how far away it is, see if they have time for lunch before storming the island, perhaps taking it over. All right, I hope this has been helpful. Thank you for watching. And as always, I'll see you in the future.